Hi friends, today is our topic about the power factor. Power factor denotes the efficiency of the power in percentage. That means if your percentage decreases, that means that power factor percentage decreases, we can say the efficiency of the system also decreases. Okay, it means the less efficient of the power usage. Suppose you give a power of 100% to an electrical machine, and that electrical machine utilized only 90% of that power. It means your power factor is 90%. That means 0.9. Okay, that means 10% of your power is lost by some means. Okay, that is the power factor. And we could say the power factor is the ratio between active power and apparent power. Means power factor is active power means kilowatt divided by kVA. Apparent power is the kVA. And its value is always in between 0 and 1. Suppose a machine require no reactive power, then we could say that its power factor is 1. 1 means its power factor is 100%. Only the resistive loads could act like that. Okay, that means its efficiency is maximum. We could say it is unity power factor. And if a machine need only the reactive power, then we could say its power factor is 0. That means its efficiency is 0, means its efficiency is poor. And there are two types of power factor: leading power factor and lagging power factor. If the current leads the voltage, then we could say that it is the leading power factor. Okay, the capacitive circuits are doing like that. And if the current lags behind the voltage, then we could say it is the lagging power factor. The inductive circuits are doing like that. I mean, the motors, coils are all acting as the lagging power factor. And I already said you unity power factor. It means if your current and voltage are in phase, there is no lagging or leading. We could say it has unity power factor. Here we have a mug. This mug has suppose 90% of beer and 10% of foam. The beer is only going to do useful work on your body, and the foam is just a wasted one. It will not do any work. The foam represents the kVA or reactive power, and this beer represents active power or useful power. This mug, which contains both foam and beer, represents the kVA, the apparent power. Here we have 90% of beer in this mug, and it is going to do the useful work. So we could say your power factor is 90%, means 0.9. And here we have a power triangle. In this triangle there is a theta in between the apparent power and real power. Okay, and here we could say the power factor as cos theta. It means real power divided by apparent power. Cos theta means power factor which is adjacent side by hypotenuse. Okay, and we have another triangle. Here we have theta in between the current and voltage. When somebody asks you about the power factor, you could simply say the power factor is the cosine of the phase difference between the voltage and current. Poor power factor will result many problems in the electrical system. The main problem, the heat of the circuit will be increased. Due to that heavy heat, the insulation and the circuit component will get damaged. And the second problem is the useful power of the system will be decreased. That means the wastage will be more. And the next one is the conductor and equipment sizes will be increased. That means the overall cost of your system will be increased. The conductor means the cable sizes. Okay. And next one is due to the high demand of the system, the overall cost of the distribution increases for the government. And there are some causes of the poor power factor. The first one is the harmonic current present in the system and improper wiring in the system. The improper wiring will cause the three-phase unbalance in the system. Suppose you have a system in which there are only few number of loads, then it would cause the voltage in your system increases. Due to that, the magnetization current also increases. It will cause the poor power factor. And next one is the current drawn by the inductive loads, and it will cause the lagging power factor, and it will also a cause of the poor power factor. And we could correct our power factor in different means. The first one is by using the capacitor banks, okay, and the second one is by using synchronous condenser. I hope you got some valuable information about this topic through this video. If you want to have more videos like this, please subscribe this channel. Thank you.